Hello everyone, welcome to week 2 of Algebra 1 where we are dividing polynomials by monomials. When you divide a polynomial by a monomial, you want to take the top term and divide it by the bottom term. So 4 divided by 4 is 1. There are two x's on top, one x on the bottom, so 2 minus 1 is x to the first. And then you divide the second term in the numerator, and negative 16 divided by 4 is a negative 4. There's one x on the top, one x on the bottom, so they both cancel out, so that leaves no x's right there. So your final answer is 1x minus 4. For practice problem number 2, 13x cubed plus 5x squared divided by x. There's an imaginary little 1 in front as the coefficient. Remember, you take the top term and divide it by the bottom term. So 13 divided by 1 is 13. There are 3 x's on top, 1 x on the bottom. So 3 minus 1 is x to the second power. And then you divide the second term on the top, on the numerator, by the denominator. So 5, a positive 5 divided by 1 is a positive 5. There are 2 x's on top, 1 on the bottom, so 2 minus 1 is x to the first. So your final answer is 13x squared plus 5x. For practice problem number 3, 21x squared plus 14x all divided by 7x. Again, take the 21x squared divided by the 7x. 21 divided by 7 is 3. There are 2 x's on top, 1 on the bottom, so 2 minus 1 is x to the first. And then positive 14x divided by the 7x. Positive 14 divided by 7 is a positive 2. There's 1 x on top, 1 on the bottom. They both cancel out, so there are no x's left. So your final answer is 3x plus 2. And then for the fourth practice problem in that section, 12x to the third plus 6x squared minus 8x all divided by 2x. Take the 12x cubed divided by 2x. 12 divided by 2 is 6. There are 3 x's on top, 1 on the bottom, so 3 minus 1 is x to the second. Take that middle term and divide it also by 2x, so a positive 6 divided by 2 is a positive 3. There are 2 x's on top, 1 on the bottom, so that leaves 1x. And then the last term, negative 8x divided by 2x, negative 8 divided by 2 is a negative 4. There's 1 x on top, 1 on the bottom, so they both cancel out, so there are no x's left. So your final answer is 6x squared plus 3x minus 4. For the next set of practice problems, it's another way of looking at the same skill. We are going to factor out the GCF. So between 18 and 6, what is the greatest common factor? 2 is a common factor because 2 goes into 18 and it goes into 6. 3 is also a common factor. 3 goes into 18 6 times. 3 goes into 6 twice. But there's an even bigger number, the number 6. 6 goes into 18 3 times and 6 goes into 6 1 time. So you're going to write down the GCF first. That's 6. 6 times what will give you 18x? And that is 3x. So 6 times 3x is 18x. And then 6 times what will give you a plus 6? It's a plus 1. So when you factored using the GCF, your final answer is 6 times in parentheses 3x plus 1. In example number 2, you're looking for a greatest common factor. It looks, because they both end in 5, 5 looks to be the greatest, and it is. Some people might get confused with the negative 5. Please don't get confused by that negative symbol. Between 5 and negative 5, 5 is greater. So our greatest common factor is 5. 5 times what will give me a negative 25x. So 5 times negative 5 gives me my negative 25, and I need to put an x with it. So 5 times negative 5x gives me my negative 25x. 5 times what gives me my positive 45, a positive 9. So my final answer, once I've factored out a GCF, is 5 times, in parentheses, negative 5x plus 9. Number 3 is a little bit more complicated, but not too much. You're still looking for the greatest common factor between the coefficients, the 16 and the 12. 2 goes into 16 and 12. So does 4. And that's it. This has 8, but 8 doesn't go in even, doesn't divide evenly into 12. So 4 is going to be our greatest common factor between the coefficients. And then you have to look at the variables. And you notice that there are 4 x's here and 1 here. If I'm pulling out the greatest number that is in both, it's going to be x to the first, because once I try to pull out an x to the second, I don't have enough here. Okay, so 4x to the first is our greatest common factor. 4x times 4x to the third, because 4 times 4 is 16, and 1 plus 3 gives me that 4 as the exponent. And then 4x times what is going to give me a plus 12x to the first. 4 times a positive 3 gives me my 12. I have 1x, and I only need 1x, so I don't need any more x's. So when I factor by pulling out the greatest common factor, 4x times, in parentheses, 4x to the third plus 3. And finally, example number 4, the greatest common factors between 20 and 50. 2 goes into them, 5 goes into both of them, 10 goes into both of them, and that's it. So 10, and then look at your variables. See how you have a 1 as an exponent, an imaginary 1, and a squared. See how I need to pull out an x to the first, because if I do pull out an x to the second, I won't have enough here. So 10 times what will, 10x times what will give me 20x to the first. 10 times 2 gives me my 20, and I already have an x, so I don't need any more x's. 10x times what gives me negative 50x squared. 10 times a negative 5 gives me negative 50x, gives me a negative 50, excuse me. I have 1x. I need a total of 2, so I need 1 more x to make negative 50x squared. And my final answer is 10x times, in parentheses, 2 minus 5x. Now please do your Delta Math assignment, Module 2, dividing polynomials.